Hello, and welcome to this video on using your calculator with recursive rules. Uh, in this particular um, video, I'm going to take a look at this recursive rule here, which is an arithmetic sequence. You should have some background on these notations and how this works. If you see here, we've got that the initial value, use of 1, okay, is 12, okay? And it's an arithmetic sequence that it generates because we're doing repetitive recursive addition of a common difference. Okay, and that common difference here is 6.2. Okay, now I'm going to show you three methods for being able to use your calculator, and they increase in complexity. If you notice these questions here, it says, what is the fourth term? What is the 15th term? What is the 38th term? Well, the deeper we get into needing to know way down the series line, like the element in that series, there's more efficient ways to use your calculator so that you're not hitting a billion buttons. Okay? Quite frankly, the easiest way to answer this first question is by doing the following. Okay, what is the fourth term in the sequence that we get from this recursive rule? Well, the first one is 12. Okay? And then I'm going to add 6.2. So I do 12, enter, and then do plus 6.2. Well, I just count along with my how many times I hit the equal sign here. So we've got the second, the third, the fourth, and we know that that's the fourth term. So the fourth term is 30.6. You could do that forever and ever and ever, but the one thing is if you start to hit this button a lot, you could very easily lose count of where you are, okay? Especially if you're asked to go like in the second question where it says, what's the 15th term? So I'll show you a way to do that. And again, you can do what I'm doing on any one of these questions for all three, but you'll be able to see the efficiency in doing one way and maybe another way. Okay? General rule is the further into the sequence you're going, the more complex a method on your calculator you would use. So this is what I'm going to do for the second question where it says, what's the 15th term? Well, if you notice in the first question, I didn't have any counter on the screen for where I was in the sequence. I was counting when I was hitting the equals button. So if I can create a counter, I can lose count while I'm hitting the equals button because I'd be looking at it on the screen. Okay, so here it goes. We're going to go second left parenthesis, which is a squiggle bracket. I'm going to say 1, and that 1 represents the first element of the sequence. Then I'm going to hit comma, and that element of the sequence is 12, because that's the initial value in the sequence, as given by the recursive rule. Second right parenthesis allows me to sort of make what looks to be an ordered pair in a table form, where the first element is the number of the sequence, the position in the sequence, and the second is the actual element in the sequence. So this says that the first element in the sequence is 12, the first term. Okay, so this is what I need to do now. I need to be able to understand how the ANDS function works. So I'm going to go like this. Second left parenthesis, second negative sign to bring up ANDS, which means the previous answer. But the previous answer has 2 elements, so I've got to tell it ANDS 1, which is the number 1 in that table. Okay? Well, if I'm going to do a counter, go first term, second term, third term, fourth term, I just want to recursively add 1 to that. And that's not the recursive part of the sequence by the common difference, but it's kind of understood that when you're counting terms, you just go first, second, third, fourth, fifth, sixth. Now, if the sequence started at use of 0, you would have started at 0, but you'd still be counting by ones most likely. Now I'm going to hit a comma and focus on the second entry, which I'm still going to use the answer function, second negative sign, left parenthesis, but now I want the second number in the previous answer. And if we see, what do I want to do with that? I want to add the common difference, which is 6.2, repetitively. Okay? Close it off with a squiggle bracket. Now when you hit enter, you see that you says the second element is 18.2. The third element is 24.4. The fourth element is 30.6, which again jives with what we did in the previous problem, but you could very liberally kind of hit the equals button until you get up to the number you want. So here I go up to 15, and I'm absolutely sure that that element in the sequence, or the term in the sequence, is 98.8. Okay? Now, again, I could continue to hit this till I get up to 38. Okay? But that's a lot of repetitive hitting. I wouldn't lose track of where I am because it's labeled with the index of the sequence, but there's another way to do this, okay? So if you go to mode and you scroll down your line where it says function parametric polar sequence, make sure that you are in SEQ, which stands for sequence. Okay, so make sure that background is darkened, and then hit Y equals. Now if you notice, that's usually the graphing window, but here it's a little different. It's laid out for sequence terms. Okay? So if you notice n min is 1, and that's important because it's representing that the index that we're starting at is 1. You would have to change that. If you were starting at 0, it would need to stay 0, but for here it's 1. Now the only thing that's a little odd here, I don't know if you realize this, but the notation that's on this screen here is reversed of what's written here. Okay? So I've got to kind of transpose this in my mind a little bit. So down here, I'll go to UN min, which in this case is 12, which is the starting value. When I hit enter, it puts it in table format, or the series format, excuse me, by putting in the parentheses. And then I'll scroll up, okay, to where it says use of n, which is giving me the rule on the recursion using the previous element. So I've got to be able to enter this portion now, okay? So the notation becomes important. There's a lowercase u under your second button with the 7. So I'm going to go second 7, and that's my u, left parenthesis, n minus 1. Well, in this mode, hitting the x button creates the n, and if you notice on the button it says xt theta n, which when we're in sequential mode, that button is the n. So if you see now I have use of u of n minus 1, which is the previous term we talked about in class, you've learned, plus 6.2. Okay? Now, that seems like somewhat complex, but the good news is when I go to second quit, I can actually just in this window type use of 38, which would be second 7, which is u, of 38, which is the 38th term. It'll take a second for my calculator to do it, but not a lot of repetitive button hitting, and it just comes out to 141.4. So those are the 3 methods you can do recursion with on your calculator to find the nth term of a series. It wouldn't matter if it's arithmetic or geometric. I use an example of arithmetic here. Again, what's the general rule? The deeper into the series you're looking, maybe you should go to your y equals window when it's in sequence mode and actually build the recursive rule, and then come to this window and just do use of whatever number index you're looking for. If it's very early in the sequence, you could probably just do the old school middle school trick of seed the calculator with the initial term, hit enter, and then do your common difference a couple of times. Here, where you're getting into, it's not a lot of terms, but it's not few terms, there's a good time to use the table method. So feel free to watch this. Mastering this on your calculator is a help. And again, always follow the directions for what method you need given the teacher's expectations.